is going to be having a look at something that you're probably relatively familiar with, but don't really understand in too much depth from Key Stage 3, because you'll have done a very simple practical Key Stage 3 where you've got universal indicator, and either by paper or by solution, you've added it to a number of different substances and you've identified where those different colours, what different colours come up. So you'll probably remember pH 7 neutral is green. Those strong alkalis are purple and the strong acids are red. So you'll probably remember these. You might remember sort of the yellow down here, etc. Now, this in reality doesn't really help, because if I'm, let's say, trying to do a neutralization reaction and I'm trying to identify when a pH change occurs, then it's very difficult to identify that point using a pH scale, because what's going to happen is the colour is just going to gradually change along this gradient. So as the colour changes, it's just going to gradually change a little bit by a little bit. So if you're trying to pinpoint a precise moment, someone might see yellow, someone might see yellow here, and someone might see a yellowy colour here, right? I mean, it's not 7's obviously green, but you get the idea. These are sort of quite close together in terms of their colour. Now, a value of 2 on the pH scale is 100 times the difference in concentration of hydrogen ions. So that's a massive difference, and those colours are very similar. So this is not a very good way of doing it. If I want to identify a specific point where a colour changes, I would use a two-way indicator such as this. I mean, here are some examples. Now, two that you need to be aware of. First is phenolphthalein. Now, the story that I always remember is, and it might be true, it might not, it's probably not, but it's a good sort of visual to remember this, is my chemistry teacher when I was at school had a child, and when she was born, she was quite constipated, which means she couldn't poo. And for those of you that have ever may have a younger brother or a sister and have seen baby poo, it's quite distinctive. Now, she was struggling to have a poo, so they gave her a laxative to help things flow a bit better. And now babies have quite a lot of milk in their diet, which is quite basic. Okay, I know the diagram before said it had a pH of 6, but I always remember it as quite basic. So it would be up here, and as a result, when that baby pooed, the poo came out bright pink. And being able to visualize that is something that allows me to remember that the color change that you get here. So it's pink in alkali because baby poo is alkali, and it's colorless down here in acid. Other one here you need to be aware of is this one, which is litmus. You've got red litmus and blue litmus. The only difference is what they are at pH 7. So the litmus red is red at pH 7, litmus blue is blue at pH 7. Now, if we have a look at universal indicator is a mixture of different indicators. There's one more here that you need to be aware of, and that's methyl orange. Methyl orange is yellow in basic conditions and red in acid conditions, which is why it's called methyl orange, because its neutral is set, or when it changes, it's orange. Now, universal indicator is a mixture of a number of different indicators, because different two-way indicators change their pH at different pHs. So if I go down and have a look, most of these in the acid column are either pink or yellow. So pink and yellow, or red and yellow, is orange. So you get sort of red colours and your orange colours down here, because that's what this combination of colours is. Most of these down here, I mean, are red or pink and blue. Red and blue give you purple. So down here in the very alkali colours, you get purple. And then sort of down here, you've got a lot of blue and yellows are green. So what happens with universal indicator is if it gets to pH 3, then this one is yellow, this one is a purple colour, this one is a red colour, this one is a colourless colour. So at pH 3, though, that combination of colours will give the colour of the universal indicator. So universal indicator constantly changes colour because the different indicators that are mixed in together are changing their colour at different pHs. And you don't necessarily need to remember that at GCSE, but you do need an appreciation that these indicators change at different pHs. You don't need to remember what pHs they change if they ask you a question, they will give you those, but you just need to be aware of this.